Welcome to Voice Bootcamp, a global name in unified communication. Hello, my name is Faisal Khan, CEO and founder of voicebootcamp.com. In this series of CCIE Collaboration Self-Study Kit for version 2, I'm going to give you a little bit of overview about the upcoming changes that are coming in, and going to give you a demo of our first chapter of SIP troubleshooting with Call Manager. Now, as you know that July 23rd, approximately around July 23rd, 2018, Cisco is changing the CCIE Collaboration Lab and is moving to a new format pretty much across all the CCIE, where you are more focused on troubleshooting the platform. Now, CCIE Collaboration 2.0 has a different outline than the current version that is going on. The outline that Cisco has laid out is, for example, they focus on a lot of protocols and APIs, followed by infrastructure and quality of services, where you focus on networking side of the topic. It will go into call control dial plan, followed by end user, endpoint, and user management and mobility. Then it does cover edge services such as telepresence, expressway edge, as well as control. Media resource, Cisco meeting server, call recordings are also covered as part of the topic. Collaboration application and evolving technologies. Now, these are not necessarily detailed topic. They're basically the high-level headline. If you look at the outline on our website, you will see that a more detailed description is provided. Now, protocol and APIs is one of the first chapters that Cisco is focusing on, where it gives you an overview about capturing and analyzing troubleshooting IP collaboration. It focuses on troubleshooting SDP and media negotiation, analyze troubleshoot SIP identity headers. It will capture, analyze troubleshooting media protocols such as H.323 and various other. Design, implement, troubleshoot DTMF relay. It will focus on capturing, analyzing troubleshooting messaging protocol, legacy telephony protocol, utilizing various troubleshooting utilities and APIs to help you day-to-day troubleshooting. Now, we're going to first give you a quick overview about the SIP signaling and SIP media negotiation as a kind of a demo to show you what we are developing. Now, as far as capturing and analyzing troubleshooting sections, we'll focus on SIP, H.323, MGCP, and SSCP. Now, for the purpose of this demonstration for this particular video, we're going to focus on SIP. Now, SIP protocol, which is basically a signaling protocol that is used to establish, manage, and terminate sessions over an IP network. Now, SIP has been evolved for many years, and various RFC or request for comment has been released. But the core protocol that was originally defined was RFC 3261. Now, one of the advantages of SIP protocol is that it is based on an ASCII character, so that it is quite faster and is easy to, develop application, because a lot of people are familiar with that. Now, another advantage of SIP protocol is that it is based on internet-related protocol. For example, most of the SIP messages or response are very familiar with the developers, because they either are involved in day-to-day internet protocol such as HTTP GET OK, response, DNS, SMTP. These are all different protocols that are consist within a SIP environment. Now, developer who may be used to programming for internet will probably find it easy to develop applications that are around SIP protocols. Now, SIP endpoints, which are often known as user agent, we will go through a few of them. Now, the question is, a lot of people ask, okay, what is SIP and what components do I have in SIP? So here we're going to give you a little bit of snapshot about what is basically SIP. In SIP consists of SIP messages, of course, which is often request and response and headers. It also have a user agent, which is usually the endpoint, followed by media negotiation. So in media negotiation, we will talk about a session description protocol, offer and answer model, early offer versus delay offer, early media, and DTMF relay. Now, user agent, which is user agent client, basically the endpoint, can be categorized as user agent client or user agent server. Now think about a Cisco IP phone. It can act as client as well as server. So when Cisco endpoint is initiating a connection, like for example, would like to establish a call, you dial the number, it becomes user agent client, or often known as UAC. UAC is a device that is going to initiate the request, whereas someone has to respond to that request, and that is often known as user agent server, or UAS. Now, a server or an endpoint could act as a UAC in one call and can act as UAS on a different call, so the role can be reversed. User agent servers send a response to the request, such as call manager server, could be the phone itself. Now most SIP devices can work both UAC or UAS. They both initiate and accept request. Now you probably heard a term called B2BUA, or back-to-back user agent. Cisco Call Manager and Cube, or Unified Border Element, can act as back-to-back user agent, or B2BUA, as opposed to proxies only. Cisco VCS or Cisco Expressway operate as both proxy and B2BUA. Now SIP, which was originally defined in RFC 32, various messages, and there are many different messages that exist in SIP. We will go through quickly a few of them to make sure you are fully aware of it. Now, one of the things about the new CCIE Collaboration lab is that there's a lot of emphasis on troubleshooting, diagnostic, and ability to understand or read logs. Now, you have to have a very good detailed knowledge about the protocol and the product in order for you to be able to troubleshoot something properly. So initially, you're supposed to be able to troubleshoot a network based on a given topology, followed by you're supposed to be able to analyze a trace file and provide a proper diagnostic. Keep in mind, those diagnostic sessions will involve you understanding the logs or traces that include this type of messages. So it is extremely important for you to understand that. Now, a SIP contains various request methods. Invite is one of the most common. An invite message where a user or SIP service will be invited to participate in a multimedia session. Now, of course, when you invite someone has to acknowledge that invite, kind of like a TCP three-way handshake, that is done by using ACK, or acknowledgement. Now, acknowledgement confirms the client has received the final response to an invite request. When the endpoint is ready to hang up the call, they will initiate a bye message or terminate an existing session, which can be sent by the user agent. Cancel, where cancel pending request does not terminate a session that has been accepted. However, option will allow you to query various capability of the servers, such as option ping alive, keep alive, option ping. Register is a server that handles a user registration for a particular domain. Now, in addition to the previous messages that we have talked about, there are many different other messages that you may need to get familiar with. And each one of these messages were defined in their different RFC. Info, for example, where it's contained information regarding the call establishment, so the user can look at that particular message and have a better understanding about what's going on. Prac, which is to acknowledge a provisional response. Provisional response, prac, mostly used in early media. Then you have a subscribe. When you are using KPML SIP DTMF format, you will have to subscribe to a particular event, and that is what this message will be used for. In response to a certain event occur, you may also need to use a notify message to notify a client. Update will allow you to update a parameter of a session that is being set up. Message that contains a SIP instant message. And then, of course, you have SIP refer, which refer one UA to communicate with another UA. Now the publish, which is to publish the UA state information to a compositor or presence server. So when you pick up a handset or you dial a phone number, your hand device will send a SIP invite message to the next hop. A SIP invite message, if you look at that trace, you will see that the initial traffic is known as called the invite message, which is the request. Followed by you got the destination address that you want to reach, or known as SIP headers, the phone number that you're trying to reach. In this case, 1-877-252-3340 at the following IP address, followed by the SIP version 2.0. So this is the first most important thing when you are debugging or analyzing the packet. You need to understand what these information means. So part of your CCIE second phase or second module is diagnostic. Then they might give you a trace file with this information, and you need to be able to troubleshoot that. So for example, if I look at this message, I know where the user is going. I know what version they're using. So if it is other than 2.0, then that could be an indication of a problem. Also, I know whether they're using a KPML DTMF or SIP notify event. It also tells me if early offer is included or not, or if a SDP session has been established or not. So by looking at these trace file or logs, I can get a lot of information about the status of the call, whether it is certain information is being used or not. Now a SIP headers contains a field. For example, if you're looking at where the call came from is considered to be a SIP header. To is a SIP header, and using a script you have the ability to override or change these headers as you need them. But every SIP messages will contain these headers. And again, it is important for you to understand these headers, because obviously throughout your career you will be required to either modify them or have the ability to read them out to find out the proper destination. SIP response, on the other hand, will every time you send a request, there has to be a response coming back, and the response that comes back has some certain information. So here's the example of SIP response that is saying that not found, or 404. 404 is an indication that the target was not found or does not exist. And of course it tells you what version of SIP it is using. Now these are predefined SIP response code where different response code, for example, provide different experience or I guess notification. For example, when you dial someone, so you pick up the handset, you dial an extension and the phone is ringing, the other side is going to ring back. So that is called the response code 1XXX. 100 stands for trying, meaning that you're trying to ring the phone. 180 indicate the phone is ringing, and 183 that the early media has already been established. Anything with the response code of 2, for example 200 OK, which is to acknowledge that the packet has been the action has been successfully received, and then of course you will acknowledge that as well. 3XXX is indication of redirection, another SIP element that needs to be contacted in order to complete the request. In this case it could be a temporary destination, it could be another proxy server or whatnot. 4XXX usually represent client-side error, meaning that certain requests may contain bad syntax or information that may not necessarily be available, such as host, the phone number you're trying to dial may not exist or was not found. In that case, the other party will send a host not found messages. If the other party is busy, for example, will send you 486 error messages. Anything with the server side issues, unable to, let's say, execute certain things, is going to initiate a 5XXX response code. 503, which means service unavailable. 6XXX, which basically called global failure, which is busy everywhere or decline the call. So again, it is important for you to understand the response code and at least the type of the error code is for. So if I'm reading at 4404, that I know the error is not on my side, it is actually on the client side, because the host may not be found or the number may not exist, and so on and so. A basic SIP call where a phone will initiate, you will dial a number and the call will go to call manager. In this case, the phone will initiate an invite message first. Once an invite message is initiated, the call manager will respond back with 200 OK should everything goes fine. And of course, the phone will then acknowledge that information back to call manager, at which point the RTP will be established as a session established. Now, at that moment, you're talking, you are gossiping, whatnot. You decide to hang up the call. As soon as you hang up the call, call manager will notify the phone to hang up. And then, of course, the phone will notify the call manager successfully saying, okay, the call has been terminated. So this is a very basic SIP call flow. Now, if you look at a basic SIP call flow with a B2B in between, such as in this case, a call manager. So the IP phone will send an initial invite message to call manager. Call manager will then look up the number and then send another invite message to the queue or the final destination. Now that remote site will then send an acknowledgement with 200 OK. So that means a successful connectivity. Call manager will then, of course, on behalf of the queue, notify the phone that saying yes, the endpoint is confirmed. The phone 1 will then send an acknowledgement back. Call manager will relay that acknowledgement back to queue. At that moment, the queue and the phone 1 will then establish a session. Now, when the phone, I guess the end of conversation, you hang up the phone, the queue, which is basically the terminating device, is going to send a bye message to the phone 1 and asking the phone 1, confirming the phone 1 that the call has ended. Of course, phone 1 will then acknowledge that by using 200 OK, saying, okay, everything is good to go. Now, this is a very SIP call setup with call manager and CM, and as well as queue. Call manager and the queue and a service provider. So as you can see, there basically you have one additional SIP trunk service provider. All you're doing basically establishing connectivity from phone 1 to all the way to the service provider SBC. So the process remains the same. From the phone 1 to call manager, an invite message. From the call manager to queue is another invite message. From the queue to the service SBC, service provider SBC, also another invite message. And of course, the response will go back exactly the same way. 200 OK, 200 OK, followed by 200 OK. Once all the acknowledgement has been confirmed, then the RTP will be established between them. But again, keep in mind, if you hang up the call, the service provider SP will then send a bye message to the phone and asking the phone to hang up. So that's the overview about the basic call setup within SIP. Now, when a SIP phone establish a call, or you pick up the handset and you dial the phone number, it does a lot of negotiation, and media negotiation is a vital part of the call. It will dictate whether the phone will support an audio call versus video call, or the codec is supported, certain codec is supported or not, RTP ports that are supposed to be used, and so and so. Now, SIP will leverage the session description protocol, or known as SDP, for the capability negotiation. And SDP will then use either offer or answer model that are described in RFC 3264 to negotiate the media using SDP protocol. Now, again, you may not necessarily have to remember the RFC 3264 or read about it, but you may need to know that for the written exam. Now, offer and answer model, where one endpoint will send an offer via the SDP containing all the capabilities such as what codec to use, whether the audio or video is supported or not, and so that you wish to negotiate with the other party. Now, SDP on the other hand contains the M line information. Now, this is very important. Remember the debugging that we saw earlier, or the trace file? There you will find a field that starts with the word letter M. The M represent the media stream. What kind of media it is? Is it an audio call? Is it a video call? Or is it a content channel? So pay attention to that particular line, because you might be given a trace file to investigate or diagnose, and you may need to observe that particular letter to indicate what kind of call it is, or if certain media capability was there that is not supposed to be there, but it's not there. So it's extremely important to have a very good knowledge about the theoretical part of it. Now, the receiving endpoint will then send an SDP and will send an answer SDP session description protocol that contains the same or a subset of capability received in the original order. So if I send a request to you, for example, let's say I say M equal audio and M equal video, you must respond back with the line M with very similar information in it. For example, audio and video. It must match exactly, otherwise it will not work. This is an example of SDP offer. Now, you notice how there is no invite information. Why? Because that is before. So the invite message happens to be just above that. If I take a look at this packet, you will see there is M right there and M right there. So the M indicates that this packet contains media. Now, what kind of media? Take a look at it. The first one says audio, second one says video. So it supports both audio and video. In addition to that, that line right here will indicate many information. For example, 0 represent that that I'm looking for audio with PCMU or ULAW and MULAW and ALAW codec. Both are offered within your packet. It also sends G729, which is 18, as you can see. It also sends you what codec will be active, in this case ILBC, and also the codec that is going to be used for the video, H264. Now, the response that comes in, or answer, will have very similar. This is the packet for answer. So as you can see, this will be very similar to it. M, audio, M, video. Now, there are two most commonly used negotiation technique we use in SIP, early offer and a delay offer. An initiator of a call, such as when I am establishing a call and I'm calling you, and I can send an SDP offer within the invite message, the initial packet. And when I do that, so basically when I dial you, I'm sending, say, hey, I can support both audio and video. So that is often known as the early offer, where you are sending the invite message and SDP together on the same packet. The receiving end can send an SDP offer in response of the invite message if in case the SDP did not include in initially. So for example, what does this mean? I call you, but I did not send you the SDP. I just simply send you an invite message. And when you did not receive the SDP from me, you're going to send back your SDP toward me, or your capability toward me. So what happened is, in this scenario, I have to make a decision of and negotiate with your offer. Early offer, on the other hand, answer is sent in a response with usually 200 OK. And in a delay offer, the answer is typically sent in acknowledgement. So here's an example. IP phone establishing an invite message to the call manager. So send an invite message with SDP. which is the offer. And the call manager is sending an acknowledgement with the SDP as well in an answer packet. And of course, the phone 1 will establish an acknowledgement, but in acknowledgement, it does not include the SDP because it was already included in offer and answer stage, which means it is an early offer. Whereas a delay offer, there is no SDP information on the initial invite message. So when the packet goes this direction, call manager says, hey, you did not send me an SDP, so I'm going to send you my capability, which is done at this stage, 200 OK, where it's making an offer. Phone 1 will then acknowledge that with the same SDP information in return. So that is called the delay offer. Delay offer is when I send a call to you, your device will have to determine if it received my capability. If it doesn't, it's going to send me his capability so that I can negotiate the capability between you and I. So that is basically about the two type of negotiation technique that we use: early offer and delay offer. Delay offer, where the originating party wait for the terminating party to send their offer, whereas early offer, the originating party will send a call invite message along with the SDP within the same packet. Now the DTMF. The DTMF is very important in SIP environment due to the nature of SIP being in-band technology most cases. So there are three types of DTMF method for passing DTMF digit in SIP network. You got the RFC 2833, you got the SIP notify, and then you got the SIP markup language, or known as the KPML. Now DTMF's RFC 2833, which is basically your data is digit stream. Digits are usually passed within the RTP stream. So this is when you're talking, hello, how's it going, the conversation, you are actually passing your digit in the same path as your RTP. Now, as we all know that RTP happens to be UDP protocol. So when you and UDP not being reliable. So when you're entering digit, you want to make sure that that is reliable. And that reliability will depend on whether it is using TCP port or UDP port. So in this scenario, if you're going to use RFC 2833, you're sending the digit as far as the UDP port. Now, if you take a look at this particular message right here, when you're sending in an offer, you'll see that DTMF right there, the telephone event. That's an indication that you have RFC 2833 DTMF relay right there. Whereas the answer should contain very much something similar to that as well. Telephone event /800 8000, and then of course the code 101. The second type of DTMF relay is called a SIP notify, where the digits are passed with the SIP notify messages in the telephone event. It negotiates in a call info negotiated in the call info header. So when an offer is sent, you will see there's a call info where you will be negotiating the DTMF. So DTMF information will be sent throughout this messages. The answer will also contain very much something similar, where you'll see allow event and it will tell you telephone event. That's an indication that you're using SIP notify DTMF relay. So in case when they give you a debug message, trace file to diagnose, and they'll tell you that, hey, identify what kind of DTMF they're using or some sort of DTMF related information, you want to be able to monitor and identify this. If you are seeing something like this, for example, this type of information, that means that you're using RFC 2833. Whereas if you are seeing something called call info, which is the header, where the SIP notify will be negotiated, and then it says method is notify. So that's an indication that you're using SIP notify DTMF relay. If, in case they ask you to diagnose a particular a trace file. Then DTMF relay SIP notify, where response in an answer packet. Now how do I know? Again, if I go back, look at this. The call for information will be available in the invite message right there. See, it's an invite message, right? Call info. Whereas if you're looking for allowed dash event, you're looking at under 200 OK. That's basically acknowledgement, confirming that it was successfully received. So allow event will be under answer, and call info will be under invite messages. Method will indicate what kind of method you're using. Now, in a DTMF relay SIP notify, your digits are passed in a payload of the notify message. So you will see there will be a traffic called notify, which will contain the payload. And if the payload is obviously contains certain digit, you'll see the content length will be greater than 0. And here you can see the sequence is notify. Now the last and final DTMF type that you have is called SIP KPML. Now KPML is very similar to an XML kind of a concept. It will pass DTMF information or digit in a SIP notify message using KPML events. When you are sending an invite message or offer, you will see something called allow event presence KPML. So that's an indication you're using SIP KPML for your DTMF. The response will contain very much similar as well, allow event KPML. Now the KPML is kind of like sending a request and getting a response. So when you're sending a KPML packet or digit DTMF, the first thing that the phone has to do is subscribe to it. It has to send a subscription to KPML, meaning requesting to use KPML. So you will see that there will be a packet called subscribe, and you'll see the event is KPML. You'll see the content type being request, KPML request plus XML, and you'll see the content length is greater than 0. So greater than 0 means this is an SDP information, and it contains some XML code, which again indicates the KPML request method. And what is very important is the pattern. The pattern means what numbers you're allowed to dial. So in this case, this pattern will indicate that you're allowed to dial any number between 0 to 9 plus ABCD. So we'll talk about that more details a little bit later. So this is the information that indicate basically included when you're trying to subscribe to KPML. Now let's say you want to send a digit. You press 1. You want that 1 to go along with among the call. Well, if the event is KPML, meaning that if you're using KPML SIP DTMF relay, content type KPML response now. So it's no longer request. See that? Your response to that. So KPML, the content length again always going to be 0. KPML response will be the XML code with the digit that you are trying to send. Like for example, the digit 1. In this case, the digit 1 will be passing within that particular message. If you press digit 2, then the next notify message will be initiated as well. Now, this is basically your DTMF. So you got this RFC DTMF, which is in-band. You got the SIP notify, and then you have the DTMF relay called SIP KPML. Now, when you use DTMF, there are some restrictions that you need to pay attention to. If you are going to use RFC 2833 DTMF, which supports the passing of MTP, this was used to support the DTMF tone for transcoding or the use of RSVP agent feature, which is basically for call admission control. DTMF event through SIP signaling feature, which will add support for telephone event notification via the SIP notify. Then DTMF relay for SIP call using NTE feature, which is used to support the hook flash relay and do not support hook flash generation for advanced features such as call waiting or conferencing. SIP info method for DTMF tone generation feature, which basically dictate that the minimum signal duration should be 100 milliseconds. If the request is received with a duration less than 100 milliseconds, the minimum duration of 100 milliseconds is used by default. So the maximum signal duration is 5000 milliseconds. If the request is received within the duration longer than 5000, then the maximum duration of 5000 will be used by default. SIP notify out of band support, which allows the skinny phone and the SIP phone to kind of work together, kind of interoperability. And then last but not least, you have the KPML based out of band relay support. Now, as I said earlier, remember the SIP KPML XML, that the reg expression. Well, these are some of the expressions that you are supported. X represent any number between 0 to 9. 1 represent digit 1. X hash key star ABCD basically match any digit between 0 to 9 plus the hash key plus the star key or A, B, C or D. So these are the various patterns that you can actually include in your response. When the phone received that information in response or request, it basically indicates that these is the pattern that you're allowed to dial. If what you dial does not match the pattern, your SIP call will not be established. All right, so now that you have a understanding about the SIP overview, you know that SIP message DTMF. Now I'm going to quickly go through SIP troubleshooting tools. Now, for troubleshooting perspective, you could use real-time monitoring tools, session trace or X translator, TranslatorX. You can also use TranslatorX for cube or VCS troubleshooting, or you can also use open source Wireshark. RTMT session, which is a small plugin freely available from Call Manager server that you can download, allows you to search for call based on calling or call number. It does not depend on call detail recording. It basically looks at the trace file. Session traces only trace SIP sessions in details and can display raw SIP messages. User correlation tag can to include all call legs related to the selected call. Now, when you log into RTMT or real-time trace tools, you can go to the real-time data, and then of course you can define the number that the user dialed within the last 30 minutes or so, and it will give you whatever the entries that is available. You can of course click on that entry to read more details. You can use the call flow diagram to see as the call established from a particular phone going through Call Manager, then to the final destination, and all the invite messages that are carrying and coming back and forth. As you can see, 8183 session progress. That's an indication that you're using early media. There is a subscription. Subscript basically says DTMF KPML subscription. You can use the message details to get more details about the messages, very similar to what we saw earlier. And by looking the invite message, you can get all sorts of information as well. Now, TranslatorX tools, which is basically available for you to download from this website, translatorx.cisco.com. Though most Cisco tech engineers use this application, but for some reason Cisco does not support it, I believe. Now, what this TranslatorX tool does, it allows you to parse the trace file. You can drag and drop text or zip files into this particular application. The latest version supports cube CISP debugs, event trace, VCS diagnostic log file as well. It allows you to decode SIP, H.323, SIP, MGCP, QSIG, and ISDN Q931 messages. TranslatorX tool can be used to generate multi-protocol header diagram and provide sophisticated filtering capability. So this is an example of what translator tools look like. And again, as you select the messages, you'll see all the details very similar to what you see in a router as well. You can list all the call list. You can list all the calls that have been successful or fail, all combination. And you can click each one of them to get more details as well. So you can filter it by searching for a particular number or something that matches close to the number you're trying to reach. Then you can use the filtering capability as well. CDR view, the translator log allows you to see the CDR, which contains call detail recording, more detailed information about that call. And you can use this tool to remotely see the CDR information as well. Translator tools has a call flow sequence diagram. When you click on generate diagram, it will create the same call flow and show you exactly what's happening as the traffic goes back and forth. And you can try this out on between two phones and make a call, and you should be able to capture and create this call flow sequence. Wireshark is a third-party tools. Wireshark allows you to do a packet sniffing or analyzing. It's open source, available at going to wireshark.org, and it can also be used for VoIP calls and SIP analysis as well. This is what a Wireshark looks like. I'm not going to go into in details about Wireshark because in the CCIE exam we don't know that it's going to support it or not. All right, trace file in Call Manager. What about traces? Well, you could SIP messages in Call Manager are written to SDI trace file when appropriate trace labels are set. Now, you can also set that information by going to the serviceability trace configuration or using the analyzing manager. Now, as of version 9 or plus, both SDI and SDL traces are stored in the same file rather than separate. They're combined into a same traces file. So here's an example of how do you enable trace. You go to the trace menu, serviceability page, go to trace menu, and then of course you can select configuration and select the server you want to trace the call on. You can apply to all the nodes, so the same information will be applied to all the nodes, and then you enable whatever you need to check in order to, or whatever you want to collect. Make sure those things are checked. So here's an example. I can enable whatever information I want to collect, but of course you don't want to collect everything because then it's going to cause a serious problem with your performance. Now, by selecting SIP stack trace, which is not really needed for SIP messages, trace collection, you can use RTMT Analyze Manager, Remote Browser, Collect File, Query Wizard, or CLI. Now, most common recommended is called Collect Files, which allows you to monitor them offline. Now, you can also log into the CLI and use this command, util network capture, to capture certain traces. You can specify where to store that information by using util network capture file count, and the host where you want to upload it to. You can go to file list active log and get a list of all the files that are currently on active partition. You can type the command file get active logs platform CLI capture file.cap, which is the actual file that has been used to capture your information. So you can collect those information and analyze it offline if you need to. So that's the overview about the demo that we are going to show you what is coming in CCIE Collaboration version 2. Now, this is just a quick demo. This is not the final product, but we're going to emphasize a lot of troubleshooting and analyzing debug messages, because that's what the exams are primarily focused on nowadays. We want to make sure that we create a product that you become a efficient and professional in various troubleshooting tools that we have available within Call Manager or third-party utilities. So it's extremely important to be focused on troubleshooting. The best way to troubleshoot or learn how to troubleshoot is to continue to practice over and over the same topic, so that you ultimately face as much as possible, and ultimately you becomes a second nature to you. All right, so that's pretty much it. I hope that you enjoyed this little demo lectures on SIP troubleshooting. Like I said, sign up to our newsletters, or download our study kits, or even buy some of our kits if you find it to be useful to you. We will notify you as we develop this particular self-study kit. Our estimate goal or planning is to release the study kit by end of August. So that's pretty much it. Thank you for your time, and I will see you in the future video.